Today on the Water Table, I had the chance to sit down with Chuck Brandel again with ISG. Chuck and I discussed a lot of the technology that ISG uses on all their public drainage infrastructure, and also the process that he uses for designing these projects. Join us here at ISG for this episode. Welcome back to the Water Table. Today we're joined by Chuck Brandel again. Chuck, thanks for coming on.
Yes, thanks for joining me here in our Bloomington office, and I appreciate the opportunity to talk to you again.
Yeah, it was great. Was able to have a chat here, I guess, through the video screen here a few months ago, and good to be back on, on the road, on site here in your neck of the woods, up here in the cities at ISG's office. So. When we talked previously, a lot of what we talked about is some of the infrastructure improvements that ISG is responsible for with, public water infrastructure, things like that. So kind of want to jump off from there and dig into maybe how you guys approach some of that process a little more, and maybe some of the tools that are at your disposal that you use to design these systems, and also maybe a little bit of an investigation.
Yeah. Like we talked about last time, many of the states in the upper Midwest have public drainage systems. A lot of those public drainage systems were constructed from the late 1800s to the early 1920s, and they're in need of repair or replacement. And we work with, I'll use the Minnesota terms, drainage authorities. Those drainage authorities' job is to maintain their drainage systems. So when landowners see that there's an issue, let's say there's a blowout, or they have a field that's not draining, they contact the drainage authority. And when you have an underground pipe, sometimes you can't tell where the problem is. So we purchased a televising equipment. We've gone through a couple iterations. We have a truck that we currently run our televising out of. And we can televise from 8 inches up to, we've done 60-inch pipe. And we also have a locator on that. So if we can identify where the problem is at, we will work with a contractor and the drainage authority, open up some holes, stick the camera in, and look at the 100-year-old clay or concrete pipe. Identify the location of it, the size, maybe where there's bends, where the problems are at. And then if it's an easy fix where we see, all right, it's plugged right here, we can't get past this point, then that can get fixed. But in other cases, we see catastrophic failures where we have 20,000 linear feet of pipe that is all failing, and we're just seeing that problem come through. So we end up televising more and more and more, and then we have to look at how are we going to replace that. Are we going to do an improvement? Are we going to do a repair? Then it's time to get landowners together and start talking about what we found. Just to keep talking about it a little bit here, I had 8 meetings last week, because they all have got built up from, we don't have meetings during harvest. So we did a lot of inspection in August and September in southern Minnesota after we had floods in June and July. And we had 8 meetings where we went over what we found in televising. Some of those cases were simple fixes. Other ones were we need to repair the system. And then in other cases, landowners are looking at options to improve the systems.
Mm-hmm. Yeah, so a lot of that originated, like you said, starting with issues that are seen on the land. That's the blowouts, that's big kind of essentially holes in your field from failing, usually concrete clay pipe that was installed back 100 years ago, 120 years ago.
Yeah, a lot of what I looked at last week was 1915, 1920. There was one that was 1929. It was almost right before the crash that happened in 1929, but that's when it got constructed.
Yep, and it's been serving its life, serving its purpose for all of its life, for 100 years, and that's, we talked to, different contractors, different customers of ours that are like, yep, we dug up some old clay that was maybe installed 50 years ago, looks perfect like the day it was put in, but, accelerate that timeline a little more, you're seeing stuff a little bit differently. Also, you have those tools to look inside the pipe, and yeah, it might be looking good for when you dig down at that one section that you remove, but like you said, if you go up another 1,000 feet, that could tell a whole different story on what's under the ground.
Oh, absolutely. And just knowing where the problems are at and identifying that with the landowner. So I kind of touched on it a little bit. After we do that inspection, put together a report. In a couple cases, knowing how bad of shape some of these are in, we just go right to, here's what it's going to cost to repair. Set up a meeting with the entire watershed. The average size of the meeting of the watersheds that we talked about last week were about 2,500 acres. So you look at 2,500 acres, they might be draining that all with a 18-inch pipe or 16-inch pipe. When you look at today's standards, that's not adequate. So we have to look at what is the most cost-effective way to replace that, and how should we do that?
Yeah, and that's leading into kind of where a lot of Prinsco Pipe and other manufacturers in the industry as well that are playing that kind of supply role in this equation too, of improving that drainage infrastructure, improving that drainage capacity for these districts or these counties or whomever else. And that's kind of something else that you use that pipe camera for as well, is once it is installed, hey, let's go back and look at it and see what that installation looks like, kind of on the back end of that too. You want to talk about that a little bit?
Yeah. So we find a system and it's in need of major repair, and we're going to look at replacing that. So we go through the process, depending on if it's an improvement or repair. There's different processes. We look at a lot of different things. But on the back end, once that pipe is installed, let's say, for instance, that 18-inch pipe that I talked about is going to get replaced with a 24 or 30-inch pipe. That pipe gets installed. As the engineer for a public drainage project, I have to certify that it was installed correctly. So we do have some installation standards. But with the pipe camera that we have, we can measure slope, we can measure deflection, we can look at joint gaps, and it's just a good insurance policy to make sure that things were installed correctly, installed per your specifications, per our specifications, and we do lean on your specifications of, you guys typically for a dual wall pipe have a 7.5 maximum deflection. So we're measuring that, and if we see areas that are more than that, then we work with the contractor and fix them. What we found is by doing this, we have greatly reduced the number of redos or going back and fixing these problems. When we work with a new contractor, we do what's called a courtesy run. Because usually we televise the entire system once it's in, once we let the ground settle for 30 to 60 days. But we'll do what's called a courtesy run just to their first 500 feet or 1,000 feet. Is everything going in right? Maybe they built a new boot this year, and that way we can adjust things before we get 10,000 feet down the line. And that has worked very well in many cases, and the contractors are very appreciative of that. Our clients are very appreciative of that, because you can just avoid a lot of problems.
Yeah, and that's the biggest thing with underground infrastructure and kind of how the way things have been done, for 100 years, is put it in the ground. If it's not failing, if you're not seeing problems on the surface, then, well, it must be working, right? And that's what we're seeing with televising and the cameraing is, we can look at this stuff a lot differently. We can use some of those tools to measure that percent deflection or how it's deflecting, and maybe some of those connections or the joints or all this other stuff that kind of tells you a lot more, builds that story, tells you a lot more about what's going on underground too. So that's a huge tool that is coming up in the industry and the marketplace on, again, what you're putting in the ground. What does it look like? Well,
the other thing is, it's the farmers that are paying for this tile and this infrastructure. We can show them that you're getting what you paid for. All of the data that we put together becomes public data. We put it into a report. We do what's called a closeout report to say, this is everything that was done, built, here's how it was built, here's what's changed, here's where the connections are located. Also, before we get to that point, maybe we have one or two issues. A large rock got in the trench and nobody saw it, and we have a deflection that we need to fix. We can make sure that gets taken care of, and you get the capacity that the landowners asked for. And we know that pipe is going to last for a long time because it's in place and it's the way it's supposed to be installed.
Right. Yeah, and that was kind of a fun lesson that I had here. I don't know when this is going to be released, but here this fall is got to have that televising truck out on site. Got to go with the inspector as we were televising it, measuring the deflection, looking at all this stuff. Had the contractor there as well to kind of essentially be reviewing their work a little bit and to see what the way that things went in was all pretty good conditions by all things considered. But looking at the deflection is, well, maybe that backfill wasn't placed directly on top of the pipe, or it pushes things a little bit over, or that spoon that was cut might be a little wide in some spots, and that all comes up in some of the images and the televising that we're doing too. So that was a fun lesson on kind of the importance of the install on the front end to make sure that we're getting what we want on the back end too.
Yeah, our guy in the field, John Meyer, is who you were with, and he's got a lot of experience in the drainage industry. He's worked for a drainage authority, and then he's also worked in the private industry, worked for us for quite a long time. He really cares about it. He wants to make sure that whatever the final product is, that it is done right. So I'm glad you got to see that with the contractor, and I tell him, everything you find, mark it down, and then we'll take a review of it and see if it's something that needs to be replaced or not. So he does a great job, and he really cares about it. So.
Yeah, for sure. And like I said, that was a fun learning opportunity for myself, and that helps us build out our recommendations better as well for whether that's the backfill that you use and the spoon that we specify for that trench, how deep you're going, what type of backfill you're using, compaction levels of all this stuff, because the guidance that we can give the contractors make them that much better for, say, all the private work that they're doing. Same concept, same pipe, same flexible pipe, same dirt that they're working in. But how can we make sure that lasts that 100-year service life that that we're designing our pipe with as well?
Yeah, and we've actually worked with a lot of private contractors that have said, I want to see how my install was. I want to see, am I doing it right? Exactly what you're talking about. How's my backfill procedures? I did a pipe through a hill and it's fairly deep. I want to just make sure that that's good and everything is put back together well. So we've done those. And it's really good for us to work with the contractors in the industry, build that relationship, because we're working together to solve these drainage issues along with you guys. So.
Yep, exactly. That's what my main takeaway has always been of, hey, we're on the same team, whether that's, ISG doing the design work, us supplying the pipe, the contractor installing it, the farmer that's, going to be working over it, or the landowner that's investing in it. We're all on the same team. Is what we all want these projects to go smooth and have that service life that, that everybody's kind of putting their name behind as well. So, that inspection, fun tool, or maybe not fun, very important tool. Mm-hmm. It's also fun.
It's fun to, if you got to drive it a little bit, it's fun. Drive it back and forth.
John didn't let me drive it, unfortunately. But.
Yeah, I got to drive it a little bit, but.
But no, a great tool that is at the disposal for the industry to continue to look at this stuff, think about things differently, do things a little bit differently, and maybe that's kind of another piece to jump off on is what other tools does ISG use with either site survey or selection, modeling, things like that when you're looking at these water projects.
Well, we're in a time of great technology and technology advances, and we can do things so much faster with technology. So we have a LiDAR drone. That LiDAR drone can survey large areas fairly quickly, accuracy to under probably 2/100ths of a foot, very, very accurate. So if we have to replace that 2,500 acre watershed, all the tile in that watershed, we can fly that area instead of having somebody drive it and walk the entire area. We still have to have some boots on the ground to measure intakes. We can't see underground, locate some of the culverts and some of those things, but we can gather a lot of that survey a lot faster, which means it's less expensive, and that infrastructure project can be done more cost effectively. We've been utilizing that on drainage systems. We've been utilizing that even on some of the where we have tile systems, but also open ditch systems where we have like a FEMA event and the open ditch has blown out. We need to quickly figure out how many areas do we need to fix. We can fly the drone over that and gather that information. And it's so much more data than you can gather by walking it. You have a ton of points, a ton of data. And I've looked at some of these LiDAR surveys, and you can see the power lines. You can see some of the grasses sometimes. We have done a little bit of testing. We can shoot through like corn and take the corn out and look at what the ground elevation is. So at ISG, we use it for a lot of other things. Buildings, road projects. We've even done some projects where we've been hired by video game companies, and we did a racetrack a few years back where we flew the drone over it, did the LiDAR survey, and then gave that data to the video game company.
Nice.
I don't know much about it. I just know we did it. So it's pretty cool, though.
Right on.
So.
Yeah, for sure. Well, cool. No, that's a lot of exciting things. Like I said, it's fun tools, toys, however we want to call them. But maybe it's just tools in the tool belt for how we're looking at water on the landscape in these projects, and doing things a little bit better here looking into the future. So.
Yeah, maybe if I could add one more.
Yeah.
It's been around for a while, but GPS on equipment. Mm-hmm. I know it's been utilized for quite a long time, but it's so much. It makes things go so much faster. We have to stake alignments. We have to look at grades and elevations. And when you have some of that on the actual large equipment, either grading or digging the trench for the pipe, it saves a lot of time. So we work with a lot of contractors and others just to get that information so it can be used on the equipment after we finish a design.
Yeah, for sure. That's and I know the contractors like having that as well. A lot less operator error.
Correct.
Maybe we put it that way.
Yep.
Nice. But yeah, that's again tools in the tool belt for how we're looking at this stuff, how we're doing things different. Technology coming up in the field is pretty exciting for these projects, and how that trickles down into a lot of the other private stuff as well. When you look into the smaller project things like that. So a lot of cool things that you're working on and that you're involved with there too. So I mean, did we miss anything else? Show off or highlight? Or
well, I can do one more technology on the drainage side of things. So when we do hydraulic modeling, the hydraulic modeling software that has advanced so much, we can create videos of flooding to show how do we fix an issue, how do we solve an issue, where are the problems. What will that tile project do to your land, and will it fix that? We use a program called ICM, and we do all of our drainage improvements with that. And that technology, it's just amazing. I've been modeling for over 25 years, and what we can do now to show how things work and how effective tile projects can be to help the productivity of the land. The landowners they love to see that, but we also show that to make sure we can get it right and design it right.
Yeah, and this has been years ago when I first seen some of this in a presentation, either you or Bailey or somebody else within your office did. Is you're looking at, say that example I had right away on an 18-inch pipe that's installed in 1902, has a certain drainage capacity, certain drainage coefficient for that watershed and land that it's on. So you can model a 3-inch rain on that watershed and say, oh yeah, your wet spots, your depressional areas, you get a pond up here.
Here's the areas where the crop will die because it's flooded too long.
Right, and then you can propose, well, if we put in a 24-inch, this is what how that relieves that pressure from that land, or a 36-inch. Essentially, if you upsize your drainage capacity, add in water storage, put in wetlands, all this other stuff, that can all go in that modeling too. So I don't know if I overstated that, understated that.
No, you did it exactly right. That's how we use it for all of those things, and it's very important in looking at how we affect things downstream. If we're going to add storage, I want to make sure we get it right, and having that detailed modeling really helps us to make sure we get it right, design it to the right size so that it doesn't harm things downstream, but also design it to the right size that it can be cost effective for the project.
Yep, and I'm sure it's also good to put that in front of the farmers and landowners and say, hey, this is kind of the new shiny tool. This is what your land's going to look like if you get this project to go through.
It gives them a lot of confidence when they see that I'm showing a map that says this area floods for 3 days on your current system. They're like, that's right. That's about right. How do we fix that? And then we can show them the solution on how we fix that. So it's a really fun part of my job to show that off. We've got a great team that does actually the modeling. I get to show it off.
Right on. Yep. You get to be the poster child for
Yep,
it.
yep.
That's awesome. Well, cool. Thanks again for hosting us here at your Bloomington office, and thanks for coming on and sharing a little bit about some of the other fun tools you get to play with within the drainage industry.
Appreciate it. Always enjoy talking to you and talking about drainage. So thank you for this opportunity.
Awesome. Thanks a lot, Chuck.
Thank you.